Okay, so we are back over here, and I just want to let you know that linear regression, logistic regression, these are all just different examples of functions where you're taking in an input, you're getting an output, right? And here you're actually only getting uh, one output, but it looks like you're getting three outputs because you're doing three of them in parallel, right? Now, what I want to introduce to you is the idea of complexity. That when we were doing before, way back when we were doing mx plus b, this is not that complex, right? And I'm not saying that it's not that hard to learn. I'm saying that it's not so sophisticated. We're not taking multiple inputs, and therefore the prediction quality might be less than what it could be if we took in multiple things into account. And if you think about it, let's say we have multiple inputs, let's say x1 and x2, and then this one is really, really useful, but this one is not very, like this is not very useful. Actually, it has nothing to do with the thing that we're trying to predict at all, right? So let's say we have w1 x1 plus w2 x2 plus b. And you're thinking like, why are we putting this into a linear regression if it has nothing to do with what we're trying to do at all? What we could do is make this zero. And if we do make this zero, then this reduces to w1 x1 plus b. And effectively, this is the linear regression that we were doing before, where you have only one variable taken into account. Okay, now I want to introduce, like now that I've introduced the idea of complexity, I want to build on that. We have multiple inputs, so it's more complex, more sophisticated. The more sophisticated you get, the more well-informed your decisions are or your outputs are. But what can we do with that? Well, can we somehow get more sophisticated without having more inputs or more information to feed into our models? Well, the answer is yes. So what we can do is okay. So the goal is to increase complexity. And here, complexity isn't a bad thing; it's a good thing, right? Because we want to be more well informed, do as much with the data that we know as possible, I guess, right? Um, how can we increase complexity? And one way we could do that is by um, sort of using intermediate computations. So the solution that I'm proposing is use intermediate computation. And what does this mean? Well, let's say that we have this is our weather example, and we're trying to predict whether or not it's going to rain. And let's say we have the month and we have the day, we have or sorry, yeah, maybe we have the year, and maybe we have the wind speed yesterday, right? The day before the day that we're trying to predict, right? So maybe what we could do is we could use, and we're trying to predict at the end of this. The goal is to predict, is it going to rain or not, right? And one thing we could do is we could use logistic regression like before and do this, right? And we've already shown that example. But let's say we want to go a little bit further than this. Before calculating whether or not it's going to rain, we could calculate an intermediate value, which is, let's say, the wind speed today, or I guess the day that we're trying to predict. And maybe that takes into account all of these things, right? We want to know the time from the time, the day, you know, and the year, month, whatever, and as well as the wind speed yesterday in order to inform us of the wind speed today. And somehow it's possible that the wind speed today could influence our idea of whether or not it's going to rain today. Maybe the two are highly correlated, or maybe one causes the other. And over here, let's say there's another intermediate computation, which is the temperature today. Let's say this is an area where it only rains if it's below a certain temperature. And so we could use the information about the month, the day, and the year to get a pretty good estimation of what the temperature is today. We could also just put in, for the sake of it, just put in the wind speed yesterday in order to give the temperature today. And so all of these things together, like basically could help us inform the model. Now that we have not only the month, the day, the year, and the wind speed yesterday, we can inform ourselves of what these metrics might be, and combine them afterwards into whether or not it's going to rain today. So you might think that like how are we going to do this, I guess, right? How are we going to do this? And the answer is right now we don't know, because we don't know the stuff under the hood. We'll get to that later. But the point is that if we have intermediate computations, this could give us a better estimation of whether or not it's going to rain today than if we just use these raw inputs without doing any sort of processing to them. And so you can think of this stack right here. You can think of this as a pre-processing step to the raw data that you're getting. Um, and so I just wanted to introduce you to that idea in this video, and we'll talk about it more in the next.